This time on openFrameworks superBasics, we're building particle systems. We control their color, we add force to them, and we give them a lifespan, and we also make them appear wherever we like on the screen. Welcome back, openFrameworks superBasics. This time we're looking at making simple particle systems and building a class, which is like a little factory to make awesome stuff. It's like a prototype that we can make lots of things in the same type as. And what we're doing is we're looking at particle systems. And with the particle system, I'm going to start out really simple, show you some basics, and then move on to add some more complex ideas that hopefully you can take on and weave into projects of your own. First thing that I want to do is talk about what is going on with the particle system. With a particle system, basically what you've got is a number of particles. And if I just put in 3 or 4 or 5 particles, these are dots, and each dot moves in a direction. The most basic being that each moves independently, doesn't know what the others are doing. There's no additional behavior and interaction between the particles. And that's the really simplest thing that we can do, is to say, make me some dots and have them move in a particular way. And there's a bunch of different ways that I could do this. What I could do is I could say, here are all my dots or particles, and here's a big list of all of them, and keep track of the direction of each one. But that means that it's very inflexible, it's very difficult to keep track of things, and if we want to change stuff, it starts becoming very manual. What we could do is we could say, actually, let's just make a particle and tell the particle where it is and its direction, and that's it. And all we need to do then is just say to every single particle, hey, particle, decide where you should go next. Decide where you should go next, decide where you should go next, i.e. update yourself so that if a particle is going in this direction and it has a particular velocity, it'll keep going in that direction unless it's acted on by a force. And when we want to draw it to the screen, we just say to the particle, hey, particle, draw yourself. So what we're going to do is we're going to make a particle class, a kind of object called a particle, and we're going to give it 2 methods or functions that it understands: update and draw. I've made a new openFrameworks project, and in our base class I've kept in the standard update, draw, key press routines, etc. And then I've made a new class of particle, and I just say class, give it a name, particle. I'm going to set the size of a particle, and I'm going to say that a particle can have a position and a direction, and each of those is going to be an XY pair. And we're using a new syntax, so it's going to be GLM vec2, so it's a vector2 kind of object, position and direction. And then I write these 2 new methods that the class knows how to do, which we saw just now. One is I'm going to say a particle knows how to update itself, and a particle knows how to draw itself. Then all I need to do is make what's called a constructor. So when I decide to make a new particle, that's a routine as well, what happens. So when I say I want to make a particle, I want to have integer x, integer y, and there's a bit that I'm going to use in a minute. And that's how particles made. And what's supposed to be good practice is you have a destructor. So when you don't need that object anymore, it has a routine that knows if it needs to take things out of memory or delete stuff. And just as my understanding is it's good programming practice, here's a destructor with the tilde symbol in front. I'm going to come into my main CPP and I'm going to write these routines out. So down at the bottom, here is my particle constructor, which we specify what it looks like in the header file. So I say part of the class particle knows how to make a particle. And when we make a particle and we give it integer x, which is starting x, integer y, which is the starting y. So these are starting positions. Inside, we saw we had this vector2 object variable called position. So the position is going to be a starting x and starting y. And the direction, again, is going to be a vec2, is going to be a random x direction. So we're going to say random of -2 or 2, and a y position random of 2 or -2. So when we make a new particle, we're going to give it an x and a y position, and we're going to give it a direction randomly in any direction of x and y. And then we need to specify what happens when we tell the particle to update itself. So we say void, this is a function that's returning no values to us, we're just saying go and do a thing. It's part of the particle class, and it's called update. And all we're going to do is say, get the position and add the direction to it. And then when we say draw, again, doesn't return us anything, so it's void. It's part of the particle class, and we're saying draw. And all we need to do is, we'll draw a circle. Now, we could expand this into 3 dimensions and say, draw me a sphere, or draw me a box, or any other thing that we like in here. But for now, all we're going to do is say, OF draw circle at whatever the variable position is, and whatever we set in size. In the OF app main definition, I've made a vector that contains my new particle object. This is a class that now openFrameworks knows how to use, and I'm going to say, make me a vector big list of as many particles as I like. So it'll take this particle class object and make me a list of them. So I could make 1,000 of them in a big list, all contained in this vector called particles. When I click the mouse and drag it around, I want to make particles. So in my OF app mouse dragged, I'm going to say make me a particle called new particle, and we need to pass it an x and a y, and I'm going to say pass it the mouse x and the mouse y, so it's going to make a new particle called new particle at the mouse x and y position, and then I say push back, take this new particle I've made and push it onto the vector of all my particles. So we've got this big vector full of all these particle objects we've made. And if I scroll up to my update routine, I've got a simple for loop that says less than particles.size. Let's go and find out what the size of this particles vector is, and just tell particles I, whichever particle is a position I in the vector, so we'll start at 0 and go position particle 1, particle 2, particle 3, and on. We just send it the command update, which we saw earlier, just works out where the position of that particle should be in the particles update routine. And in the draw routine, I'm just going to set the color to be white and have a very, very similar loop where I go through starting at 0 all the way to however big my vector of particles is. And instead of saying particle 0, 1, whatever, update yourself, I'm saying particle draw yourself. So each particle will just be sent this instruction. If I scroll down, particle update yourself, and it just updates the position by adding its direction to itself. And then when I say particle draw, it just draws that circle at that position for as many as we want. So if I run my code now, this compiles and runs, when I click the mouse and drag it, I'm going to keep making new particles, these particle class objects, and putting them into the end of the vector. When I let go, it stops, and each particle is just being sent this update yourself and then draw yourself continuously in these loops, in the update loop and in the draw loop. And if I drag around, you can see each particle has its own vector, and it just continues in a straight line from wherever it was made. I can run this full screen. And now I've got a kind of simple particle paintbrush. And that's really quite cool. What would be nice is if these particles kind of had a history, so they aged. And what would be great is if I could make them get smaller as they're older. Also, it looked like they were going away and a whole bunch of other things. So we're going to add that right now. In the particle update, every time I ask it to update, it's going to add the direction to the position. So it keeps updating the position of where it is. And inside the particle, I've added this float value in the definition of the particle called size. So now a particle has got a variable inside itself called size. And we started out, when we made the particles, making the size 20. So that's the size that we're going to draw at. And I'm just going to say, in my update, if the size of the particle is greater than 1, decrease it by a little amount. And this, we're saying size minus equals 0.7, so it'll get smaller and smaller and smaller. And I could change this amount to make them live for longer or get smaller quicker. So with just every iteration, every time the particle gets updated, it's going to get 0.07 smaller, starting at 20. So now, lovely. I make these particles and they kind of disappear. What will be good is like to work out after so many updates, can I destroy that particle and get rid of it? Because at the moment, the vector of particles is just getting bigger and bigger and bigger. Bit messy, but we'll worry about that some other time. But for now, I've got these particles that I make, and as they drift off, they get smaller and smaller and smaller, which is beautiful. And I could control the start point and the generation of them to be anything that I want. What I'd like to do is change their color. And I think what I'll do is, every time I click and I'm making particles, I want them to be a random color so that each swipe it's one color. And then next time I swipe, I get a different color. So I can get these arrays or groups of different colors. So I'm going to track the hue. And if I come to my header, I'm going to track the color by adding an OF color variable called color into my definition of the particle. So in my header file, I've made an integer called hue. And I'm going to start out with the hue being 0 in my setup. And when I click the mouse, I press the mouse down before I start dragging. I'm going to pick a new hue. So in the mouse pressed routine, I'm just going to say the hue is a random of 256. So if you remember the video that I did about hue, saturation, brightness, HSB color, the link's somewhere here, we can set the brightness and the saturation so we can pick groupings of color palettes that are relatively complementary. And here the random hue goes across from red, green, blue, indigo, violet between 0 and 255. So we pick a random hue, and when we make that particle, we can now pass it the hue. So we'll pass the X position and the Y position and the hue that that particle should be. We're going to set the variable inside each particle called color. I'm going to set it via HSB to be whatever the hue is we've generated, 255 and 255. And just to make it a little bit fruity, I'm going to make it semi-transparent so we can see whether they're overlaying each other. So we're going to give it a transparency of 200. And now, in the draw routine for the particle, before we draw the particle, each one, I'm going to say, set the color to be whatever the color of this particular particle is. So all being well, I'm going to compile and run this now. Run it full screen. When I click, it's going to select a random hue. And the particles you can see, they overlay, they're semi-transparent. And when I click again, I get a random hue each time, and each one is semi-transparent. And they go off in all their different directions as a particle system. And I could make a continual emitter if I wanted, lots of other things. That's basically building a particle system out of classes. And I can make as many particles as I like now because I've defined what a particle is. There's one more thing that I'd like to be able to do, which is add a force to this. So if you could imagine the particles being washed or blown in one direction, or sort of having a weight like a gravity. So I'm going to add in an extra thing to each particle as a really simple example of how you can apply a force or simulate a force to a particle. So in the definition of the particle in the header file, you can see I've got now 3 vector 2 objects or variables: force, position, and direction. So the position is wherever the particle is now. The direction is what direction is it going in. And then I'm going to add a force. In my CPP, my main file, when I make each particle, I'm just going to set a force to be standard. And it's going to go down by 0.02. So I'm going to say force is 0x and 0.02y. And I could, if I wanted, actually say make all the particles come from here and use the mouse position to set where the force is and have the force changeable. But this is just a really simple example of how I could update by adding a force. So there's the force. And in my update, I'm going to say the direction is going to have force added to it a little bit. So even if the particle starts off going up this way, it's going to slowly have this downward pull added to it. So it does that. And it'll keep accelerating downwards slowly or in the direction of wherever I set the force. So I'm going to say add the force to the direction, and each time we add the direction to the position. So now, if I run this, run it full screen, when I click, it'll make particles. And you can see even the particles that are going up curve down and start fading away. And every time I click, I get a different hue. And I could add this particle system to anything. Now that I've built the class object, I could use that somewhere else. And all I need to do is say, make me a particle and put it into a list of particles and tell them to update themselves and draw themselves. So I could make this respond to sound or other movement. I could add it into 3D and use EasyCam and see these in 3D. And instead of drawing circles, I could draw spheres or boxes, any kind of thing that I like. There's only one more thing that I'm going to do just to overchef it and finesse it. I want to change the color as these get older. Not only do they get smaller, because they're semi-transparent, we can see them overlaying each other, but I want the color to change. So in my update, I'm just going to say, get the brightness of the color. And when we made the color initially, we set the hue randomly, but we chose 255 saturation and 255 brightness. And I'm going to say get the hue, and if the brightness is greater than 20, either change the brightness or change the hue. And I think what I'm going to do is I'm going to start out and see what happens when we change the hue. So I'm just going to make the hue slightly smaller each time, so it'll move from one end of the color spectrum to the other. So every time we update, the particle gets smaller and it's going to change color slightly. So you can see all the particles are drifting towards 0, which is red red, orange, yellow, green, blue, indigo, violet. Hue of 0 is red. So as the particles get older, you can see they're moving through yellow into red, which is kind of beautiful. That's really nice. Or if I wanted, I could change brightness or even both. So now they're going to change hue and they're going to change brightness, or I could change transparency or do all kinds of funky things with size over time. So now not only will they change hue, you can see they're getting darker as well. So that's particle systems. Really, really super simple. You can add this into anything. You can modify it to 2D, 3D. You could use lines, 3D shapes. You can make it respond to music. Leave some comments. Hit the like if you like this. Subscribe and let me know about your projects. And I'll see you on a future episode of openFrameworks superBasics from Art and Code.